Hello everyone. Do you all know what is the relation between XOR gate and the XNOR gate? So XOR gate, it is actually having the symbol this one, okay, X, Y, and this is output Z, where Z is X XOR Y. Okay, these are the two inputs to the XOR gate. Z is the output. So now if you are writing the truth table for this, for 2 bits, you know what are the combinations: 0 0, 0 1, 1 0, 1 1. So what will be the output? Output will be 0 0, it will be 0, 0 1, it will be 1, 1 0, it will be 1, and 1 1, it will be 0. So from here you can see whenever there is odd number of ones, then the output is equal to 1, and whenever the inputs are same like 0 0 or 1 1, the output will be 0. That means here you can see there is inequality. So XOR gate is also called as inequality detector. Inequality detector. Okay. So similarly, if I consider 2 input XNOR gate, it is represented like this. This is the symbol. Here you can see a bubble as it is in the NAND gate. Okay, so this is the output. So if I write the truth table of this, then it will be X, Y, Z. Here if you have 0 0, 0 1, 1 0, 1 1, 4 combinations, 0 0 will be equal to 1, this will be equal to 1, and the rest will be 0. So here we can see that when the number of input is like when inputs are same 0 0 or 1 1, then only the output is high. Otherwise the output is low, that is 0. That means this is equality detector. So from this truth table or from the symbol, you can see that the XNOR gate, it is nothing but it is the inverted XOR. Inverted XOR, when I place an inverter in front of the XOR gate, you will get XNOR. Okay, so this is the relationship between the XOR and the XNOR gate. But the thing is, now we will see some formulas for XOR and the XNOR. Suppose I am inverting one bit, okay, instead of Y, I am taking Y bar. Then what will be the output? So X XOR Y bar, this will be equal to Z output, and this is equal to X XNOR Y. Okay, and one thing you must remember, for XOR, you have X XOR Y, it can be represented as X Y bar plus X bar Y. This is from the truth table, because you know from 0 1, 1 0 both are high. That means this is X, this is Y. X, this is X bar, this is Y, and this is X, this is Y bar. So X bar Y plus X Y bar. Okay, so this is the expression for X XOR Y. So now if we are inverting one input, then we will be getting the XNOR. So how is that possible? See, X bar Y, X bar Y, this is as it is, plus X Y bar, this is, and then you are going to complement it. You know, when there are two complements, it will become the X bar Y bar plus X and Y. Two complements will cancel each other. So you are going to get this, which is the expression for X XNOR Y. So how you are getting X XNOR Y? It is again from the truth table, where 0 0 and 1 1 was equal to 1. So this is X bar Y bar and this is X Y. So this is the expression for the XNOR gate. Okay, so if you are inverting one of the inputs of the XOR gate, then you are going to get the XNOR as the output. So it is the same. If you are inverting X and keeping Y as it is, again you are going to get X XNOR Y. Same way you can prove this also. But what happens if I invert both the bits? What happens if I invert both the bits? It's like X, I am passing it through inverter, then I am giving it to XOR. X bar Y bar then output will be X XOR Y only. If both the inputs are inverted, the output will be same, Y. X bar, A bar, then XY. So XY, sorry, A bar B plus AB bar, like X bar Y plus X bar Y plus X Y bar. So this is XY bar plus X bar Y. So this is XOR gate. So if you are inverting only one of the inputs to the XOR gate, you will be getting the XNOR expression. If you are inverting both the inputs, then you are going to get the XOR itself. Okay. And now if I take X and 0, what will be the case? So X XOR 0, X XOR 1, what will be the answer? So here you can see X bar 0, X 0 bar, so it is X1, it is equal to X. That means whatever you are having as the input, that is coming as the output. So whenever you are XORing with 0, it will be acting as the buffer. Okay, and X XOR 1, so this will be X bar. So if you are giving input as X and other input is fixed to 1, you will be getting the complement of the input. That means it is acting as the inverter. Okay, it is acting as a inverter. And you can see this also, X XOR X. X XOR X, it will give you 0. X XOR X bar, it will be giving you 1. So these are some of the important relations. Similarly, we can see the input to the XNOR. See, X XNOR Y. So it is XY plus X bar Y bar. If I invert one of the inputs to the XNOR gate, you will get X XOR Y, same as XOR. Again, you can prove this, X bar Y plus X bar Y bar. So X bar Y plus XY bar, which is XOR gate. If I keep X as it is, but if I invert Y, then I am going to get X XOR Y. What happens if I invert both the inputs? Again, it is the same thing. Now, if I XOR with 0, if I XOR with 1, if I XOR with X, if I XOR with X bar, what happens? This you can say, X and X, when both are same, the output will be equal to 1. And when they complement, it will be equal to 0. So from this I can write X XNOR is this X, and when it is X XNOR 0, this will be X bar. Okay, so this is some of the important expressions for XOR and the XNOR gate. So suppose now this is when 2 inputs is given. What happens when you are giving 3 inputs? Normally in market, 3 input XOR gate or XNOR gates are not available. So to get the 3 input, you have to use the 2 input XOR only, and then you have to XOR like this, X, Y, Z, then you are going to get A. Okay, so this is the way you are going to do. So using this only, you will be writing the truth table. Zero, 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 001, 010, 011, 100, 101, 110, 111. So 0 XOR 0 is 0, 0 XOR 0 is 0, 0 XOR 0 is 0, 0 XOR 1 is 1, 1 XOR 0 is 1, 0 XOR 1 is 1, 1 XOR 1 is 0, 1 XOR 0 is 1, and 1 XOR 0 is 1. This is 0, this is 0, this is 1. So this is the truth table for the 3 input XOR gate. So what about the XNOR? 0 XNOR 0 is 1, 1 XNOR 0 is 0, 0 XNOR 0 is 1, 1 XNOR 1 is 1, 0 XNOR 1 is 0, 1 XNOR 0 is, 0 XNOR 1 is 0, 0 XNOR 0 is 1, 0 XNOR 1 is 0, okay, and 0 XNOR 1 is 0. So you are going to get this. So here you can see, there it was complement of each other when we consider 2 input, But when we consider 3 input, we are seeing that both are same for both XOR and the XNOR. How is it possible? Then that means always it is not the complement of the XOR gate. Okay, so when the number of inputs is even, like 2 inputs, 4, 6 inputs, XNOR will be complement of the XOR. But when number of inputs is odd, XNOR will have the same truth table as the XOR. Okay, it will have same truth table as the XOR. Okay, even if you want to write 4 truth table, then you can use the same procedure and you can check it and see.